clearing the malignancy. Target neutralized.
In this video, I'm going to be talking about some foods that could help with something called CAF, or in short, CAFs are cancer-associated fibroblasts within nutrient shadow zones. And Caveolin, which is like a protein, and lipid Raft-mediated endocytosis clusters exosomes at cholesterol-rich microdomains. Now, why this matters is that lipid rafts with cholesterol plus a sphingolipid is not a good thing actually, because exosomes, they actually bind to these caveolin-1 scaffolds. Their membranes are cholesterol rich, and also exosomes display tetraspanins, CD9, CD63, CD81, and integrins that partition into rafts. If exosomes have somewhere to bind and to go to, that's actually not a good thing. So what could have led to this situation in the first place could be a lysosomal membrane peroxidation, because the MVBs could not fuse to the lysosomes, so instead they fused to the plasma membrane, and now there's this situation where the exosomes are released, and now they are binding to these caveolin-1 cholesterol-rich scaffold sites. Now, the purpose of this clustering is that it's not passive. It's for signal amplification. Concentrates receptors such as TGF-br, EGFR, integrins, and enables low-dose cargo to trigger pathways. The cargo would be the exosomes, or exosomes have cargo, and it's not good. The cargo on the exosomes is meant for immune system destabilization, immune system retraining, influencing how the immune system acts, even to support the growth of cancer or to protect cancer. So the low-dose cargo triggers pathways such as SMAD and mTOR. Also, entry route control. Okay, so up next, favors selective uptake of tumor exosomes that reinforce ECM deposition, ASNA expression, nutrient sequestration behavior. That means that tumors can take up from supplements. So basically, the way that supports the tumor is CAF relevance. So CAF is short for cancer-associated fibroblasts. And CAFs and PSCs, they overexpress CAV1. Okay, now there are these endosomes that can help the exosome cargo escape, or literally continuing the signaling and metabolism that the exosomes started in the first place, such as TGF-beta, mTOR, and MAPK. But there's this process called macropinocytosis that could possibly instead change the cargo load fate, or to decoy it away, or to derail it away from its original path by enabling lysosomal degradation. Can support this cargo loading to exosome, or the cargo committing to the or the cargo going to the lysosome, which is more favorable, because then the exosomes can't do their havoc, is by supporting RAB7, leading to late endosome maturation. Late endosome maturation is a good thing, because then the endosomes are not going to have control of the exosome cargo load fate. But CAFs, which are cancer-associated fibroblasts, they often bias RAB5 retention. Now, RAB5 is basically enables early endosome fusion, which is not good. CAFs also delay RAB7 recruitment. Cargo is not going to go to the lysosome, which is more desired. Okay, now there's these things called nutrient shadow zones, which actually support tumors and to actually be avoided. And they are made by CAFs or CAF-associated. And this happens if the exosomes fuse to the cytosol. There are miRNAs that suppress GLUT expression in immune cells. Also, miRNAs also prevent mitochondrial biogenesis genes. So basically, miRNAs are a load that exosomes carry. Exosomes use miRNAs as a way to attack or destabilize the immune system. Where ASCT2 is an issue, usually from having too many bananas. So basically, ASCT2, it's basically a transporter that tumors use to absorb and use glutamine as a fuel source. And basically, metabolites like glutamine, they reinforce CAF metabolic dominance, or CAF is short for cancer-associated fibroblasts. And CAFs will eventually end up creating these nutrient shadow zones. CAFs become nutrient sinks that tumors feast on. Okay, now there are some foods here that affects lysosomal degradation bias. So these strongly promote degradation by upregulating acidification and upregulating cathepsins. So one of the first foods here is oranges with naringenin. Okay, next is kiwi. Kiwi is a protease that cleaves. Pineapple is also another good one here. Pineapple is also a protease that cleaves. It can cleave adhesion molecules like, let's say, an exosome load is binding to or clinging to an immune cell. There's machinery that allows the binding to occur from because exosomes, they use the load, they release their load to attack immune cells, and the load docks onto the immune cells to disable immune cells, but pineapple can disable that binding, cleaving adhesion molecules and machinery that is allowing that the exosome load to bind up to the immune cells. Next one is papaya. Papaya can lower STAT3 and raise STAT5. That's critical because STAT3 supports cancer cells and tumor cells. It can even destabilize STAT5 and make it difficult to bring STAT5 back from a chromatin disabled state or from chromatin being shut, or weakening the immune system, because STAT5 boosts the immune system. Next is grapes, polyphenol-induced lysosomal activation. Now that's really good, so that lysosomes can degrade exosome cargo. Also, lysosomes can fuse to the MVB. If the lysosome can fuse to the MVB, that will actually prevent the exosomes from being released in the first place. Now, lysosomal fusion to the MVB could be one of the best preventions of these nutrient shadow zones. Okay, because if the MVB holding the exosomes, because the MVB has sacs that the exosomes loads up into, and there's machinery for that too. If the MVB with the exosomes loads up on the lysosomes, then the lysosomes will degrade the exosomes and the load, preventing this whole entire issue with the CAFs, cancer-associated fibroblasts, and nutrient shadow zones. That basically nutrient shadow zones, the immune cells, they see the nutrients, but they can't get the nutrients. The nutrients goes to the tumors instead. And the last food here is a very simple food, apples. Apples also strongly promote degradation of exosome load via lysosomes. So that's it for the video. Like, comment, share, subscribe, and I'll see you in the next video.